In late December 1943, a P-38J Lightning limped across the German border after sustaining flak damage during a bomber escort mission over southern Germany. Its pilot, attempting to reach Allied lines, miscalculated his fuel and force-landed in a snow-covered field near Karlsruhe. Within a week, the twin-boomed fighter, an aircraft German pilots called Der Gabelschwanz Teufel, the fork-tailed devil, was sitting on the ramp at Recklinlers, where Luftwaffe test pilots would discover that American engineering had solved problems German designers insisted were impossible. What they found would shatter assumptions about twin-engine fighter design, revealed that counter-rotating propellers could eliminate torque completely, and confirmed that American turbocharger technology had given a 30,000-pound aircraft performance that exceeded Germany's lightweight single-engine fighters. This is the story of how German test pilots confronted the reality that American industrial engineering had surpassed German theoretical elegance, and how the reports they wrote traveled through a bureaucracy that could not accept what the data proved. Subscribe now if you want the buried stories of World War II's technological battles, the engineering intelligence that shaped air combat, the test flights that revealed uncomfortable truths, and the human cost of ignoring data. We're going deeper than any other channel. Hit that button. December 28, 1943. Recklinlers Airfield, Mecklenburg, Germany. The morning is brutally cold. Winter locked over northern Germany with temperatures well below freezing. The sky a flat gray. Wind cutting across the airfield carrying the smell of coal smoke and aviation fuel. Oberstleutnant Hans-Werner Lurch stands on the frozen concrete apron, his breath visible in the cold air, studying the aircraft before him with a mixture of professional curiosity and something darker apprehension. Perhaps, or the recognition that this evaluation will confirm suspicions he has been nursing for months. The Lockheed P-38J Lightning, serial number 4267543, sits awkwardly on German soil, its twin booms and central nacelle covered in a thin layer of frost. The twin Allison V1710 engines silent, the four-bladed propellers motionless. The aircraft force-landed 6 days ago near Karlsruhe. Its pilot, First Lieutenant Robert Hayes, 24 years old, from Texas, captured after setting his aircraft on fire, or trying to. The fire went out. The aircraft survived with moderate damage. German recovery crews extinguished the smoldering remains, loaded the aircraft onto rail flat cars, transported it to Rechlin, and now it waits. An American intruder on German territory, ready to reveal its secrets. Lurch is 31 years old, one of the Luftwaffe's most experienced test pilots with over 2,000 hours in more than 70 different aircraft types. He has flown captured Allied fighters before, Spitfires, Hurricanes, Airacobras, even one Mustang for about 30 minutes before the engine failed. Each evaluation has been educational and disturbing in equal measure. Each aircraft has revealed capabilities that challenge German assumptions about fighter design, about what is possible, about what is optimal. But the P-38 is different. The P-38 has been terrorizing German pilots for over a year, especially in the Mediterranean theater, where its combination of speed, range, and firepower has made it devastatingly effective. Intelligence reports describe it as fast, heavily armed, capable of operating at altitudes where German fighters struggle. German pilots encountering P-38s over Tunisia, Sicily, and Italy have reported difficulty catching them, difficulty escaping them, difficulty understanding how an aircraft so large and heavy can perform so well. Lurch is here to find out. He suspects the answers will be unpleasant. Behind Lurch, 3 other pilots wait in the December cold. Dressed in heavy leather flight jackets, fleece-lined boots, wool gloves, Major Heinz Bauer, 24 years old, one of the Luftwaffe's highest-scoring aces with 189 confirmed victories, a combat veteran who has fought on every front. Hauptmann Wolfgang Spicate, 26 years old, a test pilot specializing in high-altitude aircraft, later to become one of the first Me-163 Comet rocket fighter pilots. And Lieutenant Rudolf Opitz, 23 years old, an engineer pilot from Messerschmitt, brought to Rechlin specifically to evaluate captured enemy aircraft and provide technical analysis. Each man has his assignment. Lurch will conduct initial flight evaluation, assessing basic handling qualities and general performance. Bauer will conduct tactical evaluation, determining combat advantages or disadvantages against German fighters. Spate will conduct high-altitude testing, pushing the P-38 to its operational ceiling. Opitz will conduct instrumented testing with recording equipment, documenting precise performance data. Together, they will answer the question, is the P-38 Lightning as dangerous as combat reports suggest? Or are German pilots making excuses for losses that should be attributed to poor tactics or inadequate training? The P-38 has been made airworthy over 6 days of intensive work by Rechlin's ground crews, supervised by civilian engineers from Messerschmitt and Focke-Wulf, who have some experience with captured American aircraft. The damage from the forced landing was moderate, bent propellers on both engines, collapsed nose gear, cracked engine mounts, ruptured fuel lines. German mechanics fabricated new propeller blades using measurements from the damaged ones, though the blade profiles are approximate, not exact. The nose gear was repaired using parts from another captured P-38, destroyed in testing earlier this year. The engine mounts were re-welded. The fuel system was patched and pressure tested. The hydraulic system required extensive work, the German technicians struggling to understand the complexity of the American design, power-boosted ailerons, electrically operated landing gear, hydraulic brakes, all controlled through a sophisticated system that is far more complex than German fighters. The electrical system was another challenge, with the P-38 featuring generators on both engines, a complex bus system distributing power and more electrical equipment than any German single-engine fighter. But the German technicians are skilled, experienced, determined. They make it work. The most significant challenge was the engines. The Allison V1710 is a liquid-cooled V12, similar in configuration to German Daimler-Benz engines, but with one critical difference: turbochargers. Each engine has a General Electric B13 turbocharger mounted in the tail boom, driven by exhaust gases, compressing intake air to maintain sea-level pressure at high altitude. German fighters use mechanically driven superchargers, which are simpler but less efficient at high altitude. The turbochargers on the captured P-38 were both damaged, one destroyed, one repairable. The destroyed turbocharger was replaced with a unit salvaged from the previously destroyed P-38. The repairs are functional but imperfect. The engines will run, will produce power, but whether they will achieve full-rated performance is uncertain. The armament, 4.50 caliber Browning machine guns and 120mm Hispano cannon, all mounted in the nose, was test-fired yesterday. All weapons functioned perfectly. The concentration of firepower in the nose with no wing-mounted guns eliminates convergence issues and provides devastating accuracy. German pilots speak with respect and fear about the P-38's nose armament, describing it as a buzzsaw that can cut aircraft in half. Lurch walks slowly around the P-38, examining every detail with the trained eye of an engineer and combat pilot. The aircraft is large, far larger than any German single-engine fighter. The wingspan is 52 feet, 6 feet wider than a Bf-109. The length is 37 feet, 3 feet longer than a Bf-109. The empty weight is 12,800 pounds, more than double the Bf-109's 5,900 pounds. Everything about the aircraft suggests that it should be slow, unmaneuverable, a target rather than a threat. Yet combat reports describe it as fast, agile at high speed, dangerous. How? Lurch needs to understand how. The twin-boom configuration is unique among operational fighters, providing excellent fields of fire for the armament and efficient structural arrangement, but also creating significant aerodynamic complexity. The booms house the turbochargers, main landing gear, and tail surfaces. The central nacelle houses the cockpit, armament, nose gear, and all avionics. The engines are mounted in the leading edge of the wings, midway between the nacelle and the booms. The configuration is unconventional, almost bizarre by German standards. German design philosophy favors conventional layouts, proven configurations, minimizing risk through conservatism. The P-38 is radical, unorthodox, a design that should not work, but it does work. Lurch needs to understand why. The cockpit sits high, surrounded by transparent panels, providing excellent visibility in all directions. The canopy is framed but with large panes, far better visibility than the heavily framed canopies on early German fighters, comparable to the bubble canopies on late-model Bf-109s. The instrument panel, visible through the canopy, appears logically organized with large, readable gauges. Lurch climbs the side-mounted ladder to the cockpit entry on the left side of the nacelle. The entry is awkward, requiring the pilot to step over the side and lower himself into the seat. German fighters have side-hinged canopies that open fully, allowing easy entry. American aircraft have sliding canopies, requiring more acrobatic entry. Small difference, perhaps irrelevant in combat, but indicative of different design priorities. Germans prioritize ease of use. Americans prioritize structural efficiency and cockpit space. The cockpit is spacious, wider and taller than any German fighter Lurch has flown. The seat is adjustable, comfortable, with thick cushioning and excellent back support. American pilots, Lurch thinks, are comfortable. German pilots are functional. The instrument panel is comprehensive. Airspeed indicator, altimeter, rate of climb, turn and bank, artificial horizon, directional gyro, compass, all standard instruments, but higher quality than German equivalents, with clearer markings, smoother movements, better illumination. The engine instruments are duplicated for left and right engines, manifold pressure, RPM, fuel pressure, oil temperature, coolant temperature, 12 engine gauges instead of 6. Monitoring two engines requires discipline, attention, constant cross-checking. The throttle quadrant features separate controls for left and right engines, separate propeller controls, separate mixture controls, a manifold pressure regulator, carburetor air temperature controls, intercooler shutter controls. The complexity is daunting. German fighters have one throttle, one propeller control, most other functions automatic or semi-automatic. K-38 gives the pilot complete control over every engine parameter. This is both advantage and disadvantage. Advantage: the pilot can optimize performance. Disadvantage: the pilot can make mistakes that damage engines or reduce performance. A German mechanic, Unteroffizier Franz Weber, climbs up to provide the cockpit briefing. Weber is 34 years old, a civilian aircraft mechanic before the war, trained at Junkers, conscripted in 1940, assigned to Rechlin because of his technical expertise. He has studied the P-38 for 6 days, experimenting with controls. Consulting the abbreviated pilot's notes captured with the aircraft, the pilot tried to destroy them but failed. Interviewing other mechanics who worked on the previously captured P-38, Weber explains the startup procedure: battery on, fuel boost pumps on for both engines, fuel selectors to main tanks. Mixtures rich, propellers full forward, throttles cracked open 1 inch, magnetos to both, starter button for right engine first. After right engine starts and stabilizes, start left engine. The procedure is more complex than German fighters, which typically start with simple magneto ignition. The P-38's electric starters, boost pumps, and multiple fuel tanks require careful sequencing. Weber warns about the turbochargers. They are delicate, require careful throttle management, can be damaged by rapid throttle changes or excessive boost. He warns about engine synchronization. The engines must be kept at approximately the same power setting or the aircraft will yaw. He warns about single-engine flight. The P-38 can fly on one engine, but the asymmetric thrust creates strong yawing forces that require significant rudder input. Loss of the left engine is particularly challenging because the counter-rotating propellers mean the right engine creates more yaw. Weber's warnings are numerous, detailed, slightly frightening. This aircraft is complex. This aircraft is powerful. This aircraft demands respect. Lurch settles into the seat, adjusts the rudder pedals, tests the control wheel. The P-38 uses a control wheel rather than a stick, similar to a bomber, unusual for a fighter. The wheel is large, mounted on a central column, requires two-handed operation for large inputs. German fighters use sticks, allowing one-handed flying, leaving the other hand free for throttle and other controls. The control wheel suggests that P-38 is more stable, less maneuverable, designed for long-range escort missions rather than dogfighting. But combat reports describe the P-38 dogfighting successfully against German fighters. Another contradiction to resolve. Lurch locates the gun sight, a simple reflector sight projecting a reticle onto a combining glass, less sophisticated than the gyroscopic sights on some American fighters, but adequate. The sight is aligned with the nose armament, no convergence issues, point-and-shoot simplicity. He runs through the startup checklist, memorizing each step, then signals Weber he is ready. Weber climbs down and Lurch is alone with 30,000 pounds of American fighter aircraft. Battery switches on the P-38 has 2 batteries, 1 for each engine. Fuel boost pumps on, left and right, the electric pumps whirring. Fuel selectors to main tanks, left and right. Mixtures full rich, both engines. Propeller controls full forward, both engines. Throttles open 1 inch, both engines. Magneto switches to both engines. He presses the right engine starter button. The Allison V1710 cranks slowly, the propeller rotating through compression strokes. Once, twice, 3 times, then catches with a deep, burbling roar. The engine settles into a rough idle, 800 RPM, vibrating noticeably. The left engine follows the same procedure, catching after 4 blade rotations, adding its roar to the right engines. The sound is different from German engines, deeper, less refined, more industrial. The Daimler-Benz DB605 and ABF 109 sounds precise, mechanical, engineered. The Allison sounds agricultural, powerful but rough. 2 engines produce tremendous noise, the propellers creating overlapping sound waves. The exhaust from 12 cylinders per engine creating a complex acoustic environment. Lurch can feel the power through the airframe, vibration transmitted through the seat, the control wheel trembling slightly. He monitors the engine instruments as the Allisons warm. Oil pressures climb to normal, 70 psi on both engines. Coolant temperatures rise slowly toward operating range. Manifold pressures stabilize at 30 inches. Idle power. Fuel pressures show 15 psi from the boost pumps. Everything appears normal. He synchronizes the engines by adjusting throttles until the RPMs match 800 on both. The vibration decreases slightly when the engines are synchronized. He tests the magnetos on each engine, switching from both to left, checking for RPM drop. Acceptable drop, 50 RPM on the right engine. He tests the left engine's magnetos, similar results. He cycles the propeller controls, watching the RPMs change as the blade angles adjust. The constant speed propellers respond smoothly, maintaining RPM automatically as he changes throttle settings. He tests the turbocharger wastegates, manually opening and closing them, watching manifold pressure change. The turbochargers are functioning, though whether they will achieve full boost at altitude is uncertain given the repairs. He tests the flight controls, moving the wheel and rudder through full travel. The ailerons move slowly, heavily, requiring significant force even with the hydraulic boost system. The elevator is lighter, more responsive. The rudder is heavy but effective. The control harmony is unusual, different from German fighters where all controls have similar weight and response. He tests the trim tabs. The P-38 has electric trim for all 3 axes. Another innovation, allowing precise trimming without mechanical cranking. He is ready to taxi. He releases the toe brakes. The P-38 has separate brakes for left and right main gear, allowing differential braking for steering, and advances both throttles slightly. The P-38 begins to roll forward, heavy, ponderous, the twin engines pulling unevenly despite his attempts to synchronize. He compensates with differential braking, sterning down the taxiway, looking around the nose. Forward visibility on the ground is good, better than most German fighters. The high cockpit position and relatively short nose providing a clear view ahead. He reaches the runway threshold, turns into the wind, runs through his pre-takeoff checks. Mixtures rich, both engines. Propellers full forward, maximum RPM, both engines. Intercooler shutters open for maximum cooling. Fuel selectors on main tanks. Magnetos both engines. Engine instruments checked, all normal. Trim set, elevator slightly nose up, ailerons neutral, rudder neutral. Flaps down 15 degrees for takeoff. Cow flaps open for maximum cooling. He glances at the coolant temperature gauge, both engines within normal range. He takes a deep breath, advances both throttles to full power. The acceleration is startling, immediate, violent. The P-38 leaps forward, both engines howling, the propellers clawing at the air with massive 4-bladed efficiency. Lurch's head snaps back, his hands tighten on the control wheel. The acceleration is faster than any German single-engine fighter. He has flown faster than a Bf-109, faster than an FW-190. How is this possible? The P-38 weighs twice as much as a Bf-109, yet it accelerates faster. The answer is power. 2,900 horsepower from 2 engines versus 1,475 horsepower from 1. Double the weight, double the power, the acceleration is equal or better. The nose wheel lifts at 60 miles per hour. At 100 miles per hour, Lurch eases back on the control wheel. The P-38 lifts off smoothly, climbing away from the runway with authority. There is no torque, no left-turning tendency, no need for rudder correction. The counter-rotating propeller's left engine turns clockwise, right engine turns counterclockwise, cancel each other's torque completely. German fighters require constant right rudder input during takeoff and climb to counteract torque. The P-38 flies straight, balanced, harmonious. This is a revelation. German designers have always argued that twin-engine fighters are inherently inferior due to complexity and asymmetric thrust issues. The P-38 proves this wrong. Twin engines, properly designed, eliminate torque problems while doubling power and providing redundancy. He retracts the landing gear, watching the main wheels fold up into the booms, the nose wheel folding forward into the nacelle. The gear retraction is smooth, electrically driven, requiring only a switch movement rather than mechanical cranking. He retracts the flaps. The P-38 accelerates rapidly, the airspeed indicator unwinding with shocking speed. He reduces power to climb, setting 38 inches manifold pressure and 2,600 RPM on both engines, and the P-38 climbs at 3,500 feet per minute. The Bf-109 G6, Germany's primary fighter, climbs at 3,100 feet per minute. The P-38, heavier by 6,000 pounds, is outclimbing it by 13%. Lurch is 5 minutes into the flight and already the assumptions are collapsing. He levels at 10,000 feet. Adjusts power to cruise setting, 32 inches and 2,300 RPM, begins basic handling tests. Turns to the left, turns to the right, steep banks at 45 degrees, then 60 degrees. The P-38 responds smoothly but slowly. The roll rate is poor, approximately 50 degrees per second at 250 miles per hour. Far slower than a Bf-109's 100 degrees per second. The ailerons are heavy, requiring significant force to initiate rolls, though the hydraulic boost helps. The turn rate is adequate but not exceptional. The aircraft's heavy weight and large size limiting sustained G capability. In a pure turning fight, a Bf-109 would have significant advantage. But Lurch realizes immediately, as he has realized with every advanced American fighter, that American pilots would not fight that way. Why turn when you can run? Why dogfight when you can boom and zoom? He tries a loop. The P-38 loops easily, the powerful engines maintaining energy throughout, requiring minimal altitude loss. The control harmony during the loop is good. The aircraft tracks smoothly. No tendency to roll or yaw. He tries a barrel roll. The roll is slow, ponderous, taking 5 seconds for 360 degrees. The Bf-109 rolls in 2 seconds. But these aerobatic maneuvers, Lurch knows, are not how the P-38 fights. He needs to test what the P-38 does well. Speed, climb, dive, energy retention. He levels at 15,000 feet and begins speed testing. He advances both throttles to military power, 54 inches manifold pressure, and 3,000 RPM. The P-38 accelerates rapidly. The airspeed building with impressive speed. 300 miles per hour, 350, 380, still accelerating. The aircraft is rock solid, no vibration, no buffeting, the controls remaining responsive. 400 miles per hour, 410, 414. The airspeed stabilizes at 414 miles per hour at 15,000 feet. The Bf-109 G6's maximum speed at this altitude is 387 miles per hour. The P-38 is flying 27 miles per hour faster. The FW-190A8 tops out at 402 miles per hour at this altitude. The P-38 is faster than both of Germany's primary fighters. Lurch maintains the speed for 5 minutes, monitoring the engine instruments obsessively. Both engines are running smoothly, temperatures and pressures normal. The turbochargers are boosting correctly, the manifold pressure holding steady. This is military power, sustainable indefinitely. The P-38 can cruise faster than German fighters can sprint. The tactical implications begin crystallizing. If American fighters can cruise at 414 miles per hour, German fighters cannot catch them, cannot intercept them, cannot prevent them from escorting bombers, attacking ground targets, sweeping German airspace. Speed is control, speed is life. The Americans understand this. He climbs to 20,000 feet and repeats the speed test. The results are even more disturbing. The P-38 reaches 418 miles per hour at military power. The Bf-109 G6 achieves 398 miles per hour at maximum power at this altitude. The performance gap is widening. The turbochargers are maintaining power as altitude increases, while German mechanically driven superchargers are losing effectiveness. He climbs to 25,000 feet, the altitude where much of the air war over Germany occurs, where bombers fly, where interceptors must operate. He levels off, stabilizes the aircraft, advances the throttles to war emergency power, 60 inches manifold pressure, and 3,000 RPM. The Allisons howl, the turbochargers screaming as they compress thin air to sea level density, the propellers biting hard despite the altitude. The P-38 accelerates, 380 miles per hour, 400, 415, 420. The airspeed stabilizes at 420 miles per hour at 25,000 feet. The Bf-109 G6 achieves 390 miles per hour at maximum power at this altitude. The P-38 is 30 miles per hour faster, but that understates the problem. The Bf-109 achieves 390 miles per hour with its engine at redline maximum power, operating at the edge of destruction, sustainable for only a few minutes. The P-38 achieves 420 miles per hour at war emergency power, which is sustainable for 15 minutes, and can cruise at 395 miles per hour at military power indefinitely. The American fighter has both higher maximum performance and higher sustained performance. This is not a marginal advantage. This is a comprehensive superiority in the speed domain. And speed, Lurch knows from 4 years of combat experience, determines who controls the battle. The faster aircraft dictates engagement terms. The slower aircraft can only react, evade, hope. German fighters are now the slower aircraft. He conducts climb testing, timing ascents from sea level to various altitudes, with oppets on the ground recording the times with a stopwatch against altitude markers. Sea level to 10,000 feet, 3 minutes 20 seconds. 10,000 to 20,000 feet, 5 minutes 10 seconds. 20,000 to 25,000 feet, 3 minutes 45 seconds. The P-38's climb rate remains excellent throughout, barely degrading until above 30,000 feet. The Bf-109 G6 takes 6 minutes to reach 20,000 feet. The P-38 reaches the same altitude in 8 minutes 30 seconds, only marginally slower despite weighing twice as much. In a scramble situation, both aircraft would reach interception altitude at approximately the same time. The P-38's weight disadvantage is completely negated by its power advantage. But the P-38 also has range advantage. It can loiter at altitude on one engine, conserving fuel, while German fighters must either land to refuel or maintain power on their single engine. The Americans can wait, the Germans cannot. He tests high-altitude performance, climbing to 30,000 feet. The P-38's performance remains strong, the turbochargers continuing to provide excellent boost. Maximum speed at 30,000 feet is 418 miles per hour. The Bf-109 G6 achieves 395 miles per hour at this altitude. The performance gap is consistent across the altitude band from 15,000 to 30,000 feet. The P-38 is 20 to 30 miles per hour faster at all operationally relevant altitudes. He climbs to 35,000 feet near the P-38's service ceiling. Performance remains adequate, speed approximately 385 miles per hour. The aircraft still controllable, still capable. The Bf-109 at 35,000 feet is barely flyable. The engine gasping for oxygen, controls mushy. Maximum speed perhaps 360 miles per hour. The P-38 can operate effectively at altitudes where German fighters are marginal. Another American advantage that German pilots have reported but that Lurch is now measuring precisely. He tests dive performance, rolling inverted at 30,000 feet and pulling through into a vertical dive. The P-38 accelerates rapidly, the twin engines providing thrust even in the dive, the airspeed building with frightening speed. 400 miles per hour, 450, 500. The control forces increase, but the aircraft remains stable. No flutter, no buffeting. At 520 miles per hour indicated airspeed, Lurch begins the recovery. He pulls back on the control wheel with both hands. The force is significant but manageable, the hydraulic boost making the pull possible. G-forces crush him into the seat, his vision graying. But the P-38 pulls out smoothly at 15,000 feet, the structure solid, the wings undeformed. He has lost 15,000 feet in the dive. The Bf-109 can dive safely to about 470 miles per hour before experiencing severe buffeting and control stiffening. The P-38 dives to 520 miles per hour without complaint. American pilots can dive to escape or dive to attack, building speeds German pilots cannot match, pulling out at altitudes where German aircraft would experience structural failure. After 2 hours of flight, Lurch returns to Rechlin. The landing is straightforward, the P-38 touching down at 105 miles per hour. The main gear absorbing the impact smoothly, despite the aircraft's weight. He rolls out, reduces power to idle on both engines, taxis back to the apron. He shuts down first the left engine, then the right, following the proper sequence to prevent damage. The propellers wind down, the silence sudden after 2 hours of roaring engines. Lurch sits in the cockpit for a full minute without moving, processing what he has just experienced. The P-38 is fast, faster than German single-engine fighters despite weighing twice as much. The P-38 climbs well equal to German fighters despite the weight penalty. The P-38 dives better, safely achieving speeds that would destroy German aircraft. The only area where German fighters retain advantage is low-speed maneuverability, and that advantage is tactically irrelevant if American pilots refuse to dogfight. The Americans have built a fighter that negates German advantages while exploiting German weaknesses. And they have done it with a twin-engine design that German doctrine insists cannot work as a fighter. Heinz Bauer is waiting as Lurch climbs down. Bauer, with his 189 victories, his Knight's Cross with oak leaves and swords, his reputation as one of Germany's most aggressive pilots, asks what Lurch he found. Lurch looks at him and says, "Everything we believed about twin-engine fighters is wrong. This aircraft is faster than our best single-engine fighters. It eliminates torque problems with counter-rotating propellers. It maintains power at altitude with turbochargers. American engineers have solved problems we said were impossible to solve. This aircraft works, Heinz. It works too well." Burr's expression hardens. He says, "Then I need to fly it. I need to understand how to fight it." Lurch nods. "You need to understand that you cannot fight it conventionally. This aircraft controls when and where combat occurs. Our fighters can only react." Bohr climbs into the P-38 for his flight. Burr's flight profile is tactical, testing the P-38 in scenarios simulating combat against German fighters. He performs mock interceptions, accelerating from cruise to combat speed, measuring response time. He discovers that the P-38 accelerates from 300 to 400 miles per hour in 28 seconds at 20,000 feet. The Bf-109 requires 45 seconds for the same acceleration and cannot reach 400 miles per hour at that altitude. Response time advantage. P-38. He performs mock dogfights against imaginary German fighters, discovering that the P-38's poor roll rate and heavy controls are significant disadvantages in turning combat. A Bf-109 pilot who gets into a scissors or rolling scissors engagement with a P-38 will win if both pilots are equally skilled. But Boer realizes the P-38 pilot would never allow this situation to develop. If the engagement becomes unfavorable, the P-38 pilot simply accelerates away, using his speed advantage to disengage. The German pilot cannot follow, cannot force continued combat. The P-38 pilot resets, tries again from a better position, or simply leaves. Speed provides choice. German fighters lack choice. He tests the P-38's zoom climb capability, diving to build speed, then pulling vertical. From a 450 mile per hour dive, the P-38 can zoom climb nearly 7,000 feet before stalling. Its energy retention is excellent. The Bf-109 with less power and higher drag achieves perhaps 5,000 feet in a zoom climb from the same entry speed. Energy fighting, the tactical approach of managing kinetic and potential energy to maintain. Advantage favors the P-38. The American fighter can trade speed for altitude efficiently, extend in the vertical, reset engagements from superior positions. German fighters cannot match this energy performance. Boer, executing these maneuvers, realizes that the P-38 embodies a different fighting philosophy. Never commit to sustained maneuvering. Always maintain energy. Always preserve the option to disengage. German doctrine emphasizes aggression, commitment, decisive action. American doctrine, at least as embodied in the P-38, emphasizes optionality, patience, leveraging technical advantages. 8. The American approach is winning. He tests the P-38's firepower by making simulated gun runs against ground targets using the reflector sight. The nose-mounted armament with 4.50 caliber machine guns and 120mm cannon firing through the propeller arc actually. In the P-38's case, between the propeller arcs, since the armament is in the nacelle, provides devastating concentration of fire. No convergence issues. No need to estimate range for convergence. Point and shoot. The combined rate of fire from all 5 weapons is approximately 3,600 rounds per minute, delivering over 6 kilograms of projectiles per second. The Bf-109G6, with one 20mm cannon firing through the propeller hub and 2 13mm machine guns mounted above the engine, delivers approximately 2.5 kilograms per second. The P-38 has more than double the firepower. A 1-second burst from a P-38 will destroy almost any aircraft. Boer lands after 90 minutes, climbs down, says nothing for several minutes. Then, I understand now why our pilots fear this aircraft. It is not unbeatable, but beating it requires perfect positioning, surprise, and the American pilot making mistakes. We cannot count on American pilots making mistakes. We are in trouble. Wolfgang Spate flies third, conducting high-altitude testing. He climbs the P-38 to 38,000 feet, near its absolute ceiling, documenting performance at extreme altitude. The turbochargers continue functioning at altitudes where German mechanically driven. The superchargers are completely ineffective. At 38,000 feet, the P-38 maintains 320 miles per hour, remains controllable, can still maneuver. The Bf-109 cannot operate at 38,000 feet with any combat effectiveness. The TA-152H, Germany's high-altitude fighter still in development, is designed for this altitude range, but it is not yet operational. Currently, the P-38 owns the high-altitude battle space. Spake performs mock interceptions of high-flying bombers, discovering that the P-38 can climb to interception altitude quickly, maintain high speed at altitude, and has sufficient power for repeated attacks. He performs sustained high-altitude flight, discovering that the P-38 can cruise at 30,000 feet on one engine, conserving fuel, waiting for targets. This capability, single-engine cruise at high altitude, is impossible for German single-engine fighters. Redundancy provides tactical options that single-engine designs cannot match. Spate tests the P-38's single-engine performance by shutting down one engine at 25,000 feet. The asymmetric thrust creates significant yaw, requiring heavy rudder input to maintain balanced flight. But the P-38 remains controllable, can maintain altitude, can even climb slowly on one engine. The Bf-109, if its single engine fails, becomes a glider, requiring immediate search for a landing site. The P-38 pilot losing one engine can potentially return to base on the remaining engine. This redundancy, American pilots operating over Germany have learned, is life-saving. Engine failures from battle damage or mechanical problems are survivable in a P-38. In a German fighter, they are usually fatal. Spate lands after 2 hours. His report succinct. The P-38 is a high-altitude fighter without equal among current German aircraft. Its turbochargers provide performance advantages at altitude that we cannot match with our current supercharger technology. The twin-engine configuration, which we dismissed as unsuitable for fighters, provides redundancy and power that outweighs the weight penalty. We were wrong about twin-engine fighters. Rudolf Opitz flies last, conducting instrumented testing with recording equipment installed in the rear of the central nacelle. He documents engine performance at various altitudes and power settings, mapping power curves, drag curves, fuel consumption. The Allison V1710 engines, each producing 1,425 horsepower at war emergency power with the turbocharger, provide a combined output of 2,850 horsepower. This is double the power of any German single-engine fighter. The specific horsepower per pound of aircraft weight, is actually better than the Bf-109 despite the P-38 being twice as heavy. American engines are more powerful. American airframes are heavier but not proportionally so. The result is performance parity or superiority across most domains. Opitz documents control forces discovering that the P-38's hydraulically boosted ailerons reduce pilot workload significantly during high-speed maneuvers. German fighters rely on mechanical linkages, requiring significant physical strength at high speeds. The P-38 reduces physical demands, allowing pilots to maintain combat effectiveness longer. Opitz performs detailed fuel consumption mapping, discovering that the P-38, despite having two engines, achieves similar specific fuel consumption to German fighters due to efficient aerodynamics and careful engine management. With internal fuel of 410 gallons, the P-38 has range exceeding 1,100 miles, far beyond any German single-engine fighter. With drop tanks, range extends to over 2,000 miles. The P-38 can escort bombers deep into Germany, can conduct long-range sweeps, can operate over enemy territory for extended periods. German fighters with 88 gallons internal fuel in the Bf-109 have combat radius of perhaps 200 miles. The strategic implications are stark. American fighters can reach any point in Germany. German fighters cannot reach England. The range asymmetry ensures that the air war will be fought over German territory with all the disadvantages that implies. Opitz lands, downloads his data, begins analysis. The numbers confirm what the pilots felt. The P-38 is superior in almost every tactically relevant domain except instantaneous maneuverability. December 30th, 1943. The four pilots gather in a converted office at Rechlin to compile their findings. The room is cold, heated by a small coal stove that provides inadequate warmth. The desk is covered with charts, performance data, photographs of the P-38. Lurch has been writing the report for 2 days, organizing observations, formulating conclusions. The report is 49 pages, typed on an Olympia typewriter. The opening section describes the P-38's capture, repair, and preparation. The second section documents the test protocols and who flew what tests. The third section presents performance data compared against the Bf-109G6 and FW-190A8. The comparisons are sobering. The P-38 is faster at all altitudes above 10,000 feet. The P-38 climbs competitively despite weighing twice as much. The P-38 dives faster and more safely. The P-38 has more than twice the range. The P-38 has doubled the firepower. The Bf-109 retains advantages in roll rate, turn rate, and low-speed handling. These advantages are tactically significant only if American pilots choose to fight in that regime. Intelligence and combat reports suggest American pilots are trained to avoid these situations, to use their speed and energy advantages instead. The fourth section, Conclusions, is carefully worded but devastating. Lurch writes, the Lockheed P-38 Lightning represents a successful application of twin-engine configuration to the fighter role, contradicting German design doctrine which holds that twin-engine fighters are unsuitable for air superiority missions. The P-38's counter-rotating propellers eliminate torque problems that plague single-engine fighters. The twin engines provide 2,850 horsepower combined, allowing an aircraft weighing 12,800 pounds empty to achieve performance equal or superior to single-engine fighters weighing half as much. The turbochargers provide excellent high-altitude performance, maintaining power at altitudes where German mechanically driven superchargers lose effectiveness. The result is an aircraft that controls engagement parameters through superior speed, superior high-altitude performance, and superior range. German fighters retain advantages in instantaneous turn performance, but these advantages are tactically exploitable only when the P-38 pilot makes errors or is surprised. Against competent P-38 pilots employing proper tactics, German fighters are at a significant disadvantage. The fifth section presents recommendations. Lurch knows these will be controversial, will challenge institutional beliefs, will likely be rejected. He writes them anyway. He recommends immediate acceleration of German turbocharger development programs to match American high-altitude performance. Re-evaluation of twin-engine fighter designs, particularly the Bf-110 and Me-410, to determine if modifications could improve their performance to P-38 levels. Development of new tactical doctrines for fighting against aircraft with superior speed and energy performance. Priority allocation of late-model Bf-109s and FW-190s with improved high-altitude engines to counter the P-38 threat. Training emphasis on altitude advantage and surprise attacks is the only reliable methods for engaging P-38s successfully. These recommendations assume resources, development time, and institutional flexibility that Germany does not have. The war is in its 5th year. Germany's industrial capacity is under relentless bombing. Resources are scarce. Time is running out. The war contributes a combat pilot's perspective. 10 pages describing what it feels like to fly the P-38, what it means for German pilots facing them in combat, what tactical responses might be effective. He writes, the P-38 is the most dangerous American fighter I've encountered. Its speed advantage at altitude means P-38 pilots can engage when favorable and disengage when not. German pilots cannot force combat. We can only accept combat when the P-38 pilot offers it, which typically means when he has advantage. This is an unwinnable tactical situation unless we have surprise or significant altitude advantage. I recommend that German pilots avoid combat with P-38s unless conditions are heavily in our favor. Survival is more important than empty victories. We are losing experienced pilots to aircraft we cannot defeat through conventional tactics. This must stop. Spicat contributes high-altitude analysis, 8 pages of technical description and tactical assessment. He writes, "The P-38's turbochargers are the critical technological advantage. They allow the Allison engines to maintain sea-level power output up to approximately 25,000 feet, then decline gradually to 38,000 feet. German Daimler-Benz and BMW engines with mechanical superchargers achieve peak power at 15,000 to 20,000 feet, then decline rapidly. Above 25,000 feet, the P-38 has categorical advantage. Germany must develop turbocharger technology or accept American air superiority at high altitude. Given that American bombers operate at 25,000 to 30,000 feet, this is strategically unacceptable." Septet's conclusion is stark. Without better high-altitude performance, Germany cannot defend against American daylight bombing. The P-38 is part of the system escort fighters operating at bomber altitude, maintaining high speed, engaging German interceptors before they can reach the bombers. The system works because the technology works. Opitz contributes 32 pages of engineering data, performance charts, engine curves, structural analysis, systems documentation. His covering note is clinical. The P-38 represents mature American engineering philosophy: solve problems through brute force, through power, through redundancy, accepting weight penalties to achieve capability. The twin-engine configuration provides 2,850 horsepower, eliminating torque issues while providing redundancy. The turbochargers provide high-altitude performance through mechanical complexity. The result is an aircraft that is heavier, more complex, and more expensive than German fighters, but also more capable across most performance domains. Germany's design philosophy: minimize weight, maximize efficiency, optimize for specific performance parameters, has produced fighters that are excellent in narrow domains but inferior in others. The P-38 has no narrow domains. It is capable everywhere. This reflects superior industrial capacity, superior materials, and mature systems integration. Germany cannot replicate this aircraft with current resources. The 4 sections are compiled into a classified report marked Geheim Kommandosach, Secret Command Matter. The report is dated December 31, 1943, signed by all 4 pilots, addressed to General Field Marshal Erhard Milch, Inspector General of the Luftwaffe. Lurch personally delivers the report to Berlin on January 3, 1944. Milch receives the report, promises to read it immediately, dismisses Lurch. Milch reads the report over 2 days, then forwards it to Hermann Göring with a cover memorandum recommending urgent development of turbochargers and re-evaluation of twin-engine fighter concepts. Göring's response is predictable: anger, denial, dismissal. Göring insists that German engineering is superior, that twin-engine fighters are inherently unsuitable for dogfighting, that the test pilots are overstating American capabilities. He orders continued production of Bf-109s and FW-190s without major modifications. The report is filed, not acted upon, but copies circulate among technical staff, shared quietly, discussed in private. Fighter wing commanders hear rumors. American fighters are faster than German intelligence admitted. The P-38 specifically is more capable than doctrine acknowledges. Morale suffers. Some pilots begin requesting transfers to bomber units, ground attack units, anywhere that does not require fighting American fighters at high altitude. Requests are mostly denied. Germany needs every fighter pilot. By early 1944, the air war over Germany is reaching crisis levels. American daylight bombing raids are increasing in size and frequency. P-38s, P-47s, and P-51s are escorting bombers to targets throughout Germany. Luftwaffe interception attempts result in heavy German losses for minimal American losses. The kill ratios are catastrophic: 3 or 4 German fighters lost for every American fighter shot down. At this rate, the Luftwaffe will be destroyed by attrition within months. The P-38 report becomes part of the evidence base that some German leaders use to argue for strategic changes. In February 1944, Albert Speer, Minister of Armaments, meets with Hitler to discuss fighter production priorities. Speer argues that Germany must accelerate development of jet fighters, the Me-262, specifically because piston-engine fighters cannot compete with American designs. He cites the P-38 evaluation among other intelligence reports. Hitler is skeptical, influenced by Göring's insistence that German fighters are adequate. Hitler orders continued conventional fighter production with only modest allocation to jet development. This decision, driven by incomplete understanding of the technical situation, delays Me-262 operational deployment by crucial months. By the time Me-262s enter service in significant numbers, it is too late to affect the war's outcome. Meanwhile, at Rechlin, the P-38 evaluation program continues. Additional flights are conducted by other pilots, each confirming the original findings. In February 1944, mock combat exercises are organized, pairing the P-38 against German fighters. The exercises are filmed. The footage shows the P-38 consistently outrunning Bf-109s in level flight, climbing away from FW-190s, diving beyond the ability of German fighters to follow. In scenarios where the P-38 pilot maintains energy discipline, refuses to turn fight, uses speed and altitude, the German pilots cannot achieve firing solutions. Only when the P-38 pilot makes mistakes, slowing down excessively, allowing himself to be cornered, attempting to turn fight, do German pilots achieve kills. The training value is clear. German pilots must wait for American mistakes, must avoid combat unless they have overwhelming advantage, must prioritize survival over aggression. This defensive mindset, necessary for fighting superior aircraft, is demoralizing. In March 1944, a second P-38 is captured, a P-38J-10 with improved engines and updated systems. It is brought to Rechlin, repaired, added to the test fleet. The newer model proves even faster than the original P-38J5 tested in December, achieving 425 miles per hour at 25,000 feet. American continuous improvement is evident. Each new model is incrementally better. German fighters, by contrast, show declining quality as the war progresses. Late production Bf-109s and FW-190s suffer from manufacturing shortcuts, inferior materials, declining quality control. The performance gap is not stable, it is widening. American aircraft are getting better. German aircraft are getting worse. The trajectory is unsustainable. By mid-1944, the P-38 is appearing in large numbers over Europe. The 8th Air Force has multiple P-38 groups escorting bombers deep into Germany. The 9th Air Force uses P-38s for ground attack and fighter-bomber missions. The 5th 10th Air Force in Italy employs P-38s for strategic bombing escort. German pilots encounter them daily, learn to fear them, develop informal tactics for avoiding them. The most common tactic: if you see P-38s and you are not in ideal position, disengage immediately. Do not try to intercept. Do not engage unless you have at least 5,000 feet altitude advantage and surprise. These tactics, developed through painful experience, contradict German fighter doctrine but reflect the reality that engagement with superior aircraft is suicidal without compensating advantages. The captured P-38 at Rechlin is eventually destroyed in an Allied bombing raid in April 1944. The aircraft burns, its aluminum airframe melting, its secrets already extracted. The test data survives, scattered across multiple facilities, some documents destroyed, others preserved. After the war, American intelligence teams recover many of these documents, translate them, study them with interest. American engineers are pleased to discover that German test pilots confirmed P-38 performance matched or exceeded manufacturer specifications. The Germans found the P-38 fast, capable, dangerous, exactly what it was designed to be. But the American analysts also note the German conclusions about twin-engine fighters, about turbochargers, about design philosophy. The Germans recognized that American approaches were effective but could not or would not change their own approaches. This intellectual rigidity, this inability to learn from the enemy, contributed to Germany's defeat. Lurch survives the war, works as a test pilot for the U.S. Air Force during occupation, later for aerospace companies. He is interviewed extensively about captured aircraft testing. He consistently describes the P-38 as one of the most impressive American designs he flew. In a 1972 interview, he says, "The P-38 taught us that our assumptions about fighter design were too narrow. We believed single-engine fighters were optimal because they were lighter, simpler, cheaper. The Americans proved that twin-engine fighters could be equally effective if you had enough power to offset the weight and if you solved the torque problem with counter-rotating propellers. They had the power. They had the engineering sophistication. We did not. That is why they won." Bohr survives the war as Germany's 7th highest scoring ace with 220 victories. He writes in post-war memoirs, "The P-38 was the fighter I would have chosen if I could choose. Fast, powerful, reliable, deadly. Fighting against P-38s required caution, patience, perfect positioning. Aggressive tactics, which worked against Spitfires and early Thunderbolts, were suicidal against P-38s. We had to learn new tactics, had to accept defensive roles, had to admit that the enemy had better tools. This was psychologically difficult for German pilots raised to believe in German superiority. but survival required accepting reality. Bauer dies in 1957, still flying. Spate survives, becomes one of the first Me-163 Comet rocket fighter pilots. Later writes extensively about high-altitude aviation and rocket-powered aircraft. He consistently cites the P-38 evaluation as a pivotal moment in understanding the importance of high-altitude performance in modern air combat. He argues that Germany's failure to develop effective turbochargers was a strategic error that crippled the Luftwaffe's ability to contest American bombers at their operational altitudes. In a 1980 interview, he says, "The P-38 had turbochargers that worked reliably at high altitude. We had turbocharger development programs that never achieved production readiness." The difference between development and production, between laboratory success and operational reliability, determined who controlled the sky above 25,000 feet. The Americans controlled it. We lost. Oppitz survives, continues as a test pilot after the war, flies many experimental aircraft including early jets. He writes technical papers about wartime aircraft evaluation, including detailed analysis of the P-38 systems and performance. His papers are used in aerospace engineering courses as examples of thorough aircraft evaluation methodology. He argues that the P-38 demonstrated American strengths in systems integration, in combining multiple technologies into a coherent whole. He writes, "The P-38 was not revolutionary in any single technology. The turbocharger was British. The Allison engine was conventional. The twin-boom configuration was unusual but not unprecedented. What was revolutionary was the integration, making all the pieces work together reliably, creating a system that was more than the sum of its parts. That is American engineering strength, systems integration, manufacturing quality, operational reliability." The P-38 Lightning continues serving through the end of the war, accumulating an impressive combat record. Over 10,000 P-38s are produced. The aircraft achieves notable success in the Pacific Theater, where its range is crucial for operations over vast distances. In Europe, the P-38 serves primarily as an escort fighter and fighter bomber until 1944, when the P-51 Mustang gradually replaces it in the escort role due to the Mustang's superior high-altitude performance and range. But the P-38 continues in fighter bomber and reconnaissance roles through Vette. The aircraft's concentrated nose armament makes it particularly effective in ground attack, and its twin-gin redundancy provides survivability in low-altitude operations where ground fire is heavy. Post-war analysis confirms the German test pilot's findings. The P-38J achieved 414 miles per hour at 25,000 feet, matching German measurements exactly. The climb rate, range, armament, all is German testing documented. The Germans got the data right. What they could not do was respond effectively. Germany's turbocharger development programs continued through 1944 and early 1945, but never achieved production readiness. The Heinkel He-177 bomber used turbochargers, but the technology proved unreliable, prone to fire. Fighter applications were attempted on experimental Bf-109s and FW-190s, but the programs were canceled due to reliability issues and resource constraints. By 1945, Germany was losing factories, losing skilled workers, losing access to strategic materials. Developing new technologies was impossible. The twin-engine fighter concept, validated by the P-38's success, was partially adopted by Germany, but too late and with inadequate resources. The Messerschmitt Me-410 Hornets, a twin-engine heavy fighter, entered service in 1943, but suffered from poor handling, inadequate performance, and vulnerability to Allied fighters. It was faster than the P-38 in level flight at low altitude, but could not compete at high altitude where combat occurred. The Dornier Do-335 Pfeil, a unique push-pull twin-engine fighter with engines in tandem rather than side-by-side, flew in 1943 but entered production too late to affect the war, with only about 40 delivered. The Do-335 was very fast, achieving 475 miles per hour, faster than the P-38, but its late arrival in limited numbers meant it had no strategic impact. Had Germany developed effective twin-engine fighters earlier, adopting lessons from P-38 evaluation, the air war might have been different. But institutional resistance, resource constraints, and bad strategic decisions prevented this. The broader lesson of the P-38 evaluation concerns institutional learning and adaptability. The Germans captured a P-38, tested it thoroughly, documented its capabilities accurately, and wrote reports recommending specific technical and tactical responses. The reports were filed, shared among technical staff, but not acted upon at the strategic level. Why? Multiple factors. Ideological resistance to admitting enemy superiority, institutional inertia favoring existing programs over new initiatives, resource constraints preventing major new developments, optimism bias leading decision-makers to believe existing approaches would suffice. The result was continued production of fighters that were increasingly outclassed, tactical doctrines that no longer worked, and pilot casualties that could not be sustained. The Germans had the information. They lacked the will or capacity to act on it. The American approach was different. American intelligence captured German aircraft, tested them, incorporated useful features into American designs. The K-14 gyroscopic gun sight used in late-war American fighters was influenced by German Revi sights. American aircraft armor was improved after studying German weapons effectiveness. American tactical doctrines evolved based on combat reports and captured aircraft evaluation. The Americans were pragmatic, flexible, willing to learn from enemies. The Germans were ideological, rigid, convinced of their own superiority. This cultural difference, as much as any material factor, determined the air war's outcome. The technical comparison between the P-38 and Bf-109 is instructive. The Bf-109 was designed in 1934, 1935. The P-38 in 1937, 1938. The Bf-109 was optimized for low weight, simplicity, ease of production, and excellent maneuverability at low to medium altitude. This design philosophy produced an outstanding fighter for 1939 to 1941 combat, where engagements occurred below 20,000 feet and maneuverability was paramount. But the war changed. By 1943, combat was occurring at 25,000 to 30,000 feet. American bombers flying high to avoid ground fire, escort fires flying even higher to maintain energy advantage. At these altitudes, the Bf-109's mechanically driven supercharger was inadequate. The engine lost power, performance declined, and aircraft became vulnerable. The P-38, designed with turbochargers specifically for high-altitude performance, thrived in this environment. Design intent matched operational reality. The Bf-109 was fighting yesterday's war. The P-38 was designed for today's war. The engine technology gap was fundamental. The Allison V1710 produced 1,425 horsepower at 25,000 feet with turbocharger boost. The Daimler-Benz DB605 in the Bf-109G produced perhaps 1,100 horsepower at the same altitude with its mechanical supercharger. The 30% power advantage drove the performance advantage. But developing engines like the Allison required industrial infrastructure that Germany lacked. By 1943, high-octane fuel production, specialty alloys, precision manufacturing, all were areas where American industry excelled, and German industry struggled under bombing and resource shortages. The engine gap reflected deeper industrial gaps that could not be closed through engineering cleverness alone. The armament comparison revealed different design philosophies. The P-38's nose-mounted guns provided perfect convergence, no harmonization issues, point-and-shoot simplicity. German wing-mounted guns required careful convergence adjustment, created convergence zones where firepower was concentrated, and had reduced effectiveness outside those zones. Nose-mounted armament was mechanically complex. Guns had to fire through propeller arcs or between engines, requiring synchronization or careful placement, but the tactical advantage was significant. The P-38 pilot aimed the entire aircraft at the target. The Bf-109 pilot had to account for convergence distance. At short range, both approaches worked. At long range, the P-38's nose armament was more effective. The Americans accepted mechanical complexity to achieve tactical advantage. The Germans chose mechanical simplicity, accepting tactical limitations. The range differential was strategic. The P-38 could escort bombers throughout Germany, could conduct long-range sweeps, could loiter over enemy territory. The Bf-109, with its limited fuel capacity, could engage bombers for perhaps 15 minutes before needing to land and refuel. The Americans could maintain continuous fighter coverage over targets. The Germans could only mount brief interception attempts. This asymmetry ensured that American bombers always had fighter escort, that German interceptors were always outnumbered, that the tactical initiative belonged to the attackers. Range, more than any other single factor, determined the daylight bombing campaign's success. American fighters had it. German fighters did not. The human cost of the performance gap was enormous. German fighter pilots in 1944 faced a terrible calculus: fly against superior. American fighters in inadequate aircraft, knowing that survival odds were poor, or refused to fly and face military consequences. Most flew. They flew knowing they were outmatched, hoping that skill and aggression could overcome technical disadvantage, usually learning that it could not. The loss rates were catastrophic. Experienced pilots were killed, replaced by inadequately trained novices who died even faster. By late 1944, the average German fighter pilot had perhaps 50 hours of training and a life expectancy measured in weeks. They flew Bf-109s and FW-190s against P-38s, P-47s, and P-51s, and they died. Not because they lacked courage, because they lacked aircraft that could compete. The psychological dimension is often overlooked but crucial. German fighter pilots in 1939, 1942 flew with confidence, even arrogance, knowing their aircraft were excellent. Their training was superior. Their tactical doctrines were proven. By 1944, this confidence had evaporated. Pilots flew with resignation, knowing they were likely to die, hoping only to inflict some casualties before being shot down. The P-38 evaluation contributed to this psychological shift. When test pilots at Reckland confirmed that American fighters were faster, when combat pilots heard that official testing validated their combat experience, morale collapsed. Hope requires belief in possible victory. When victory becomes mathematically impossible, when the aircraft are too slow, the tactics are inadequate, the resources are insufficient, hope disappears. What remains is duty, resignation, and slow attrition toward defeat. The story of the P-38 evaluation is ultimately about the gap between what was known and what was possible. German test pilots flew the P-38, measured its capabilities, documented its superiority, recommended responses. But Germany in 1944 lacked the industrial capacity, the resources, the time, and perhaps the institutional flexibility to respond effectively. The knowledge was there. The capability was not. This gap between information and action, between understanding the problem and solving it, is characteristic of organizations in decline. The Luftwaffe in 1944 could see its problems clearly. The test reports were detailed, accurate, and comprehensive. But seeing problems and fixing them are different things. Fixing required resources Germany did not have, time that had run out, and leadership decisions that were not made. The P-38 report joined hundreds of other reports documenting Germany's deteriorating position. Filed away, noted, and ultimately ignored because there was nothing to be done. The final irony is that the P-38, which so impressed German test pilots in December 1943, was already being phased out of its primary role by late 1944. The P-51 Mustang, with its superior high-altitude performance and longer range, replaced the P-38 in the bomber escort role. The P-38 continued in ground attack, reconnaissance, and tactical roles, but its era as America's primary long-range escort fighter was brief 1943 to early 1945. Yet, even in decline, even being replaced by better aircraft, the P-38 remains superior to German fighters in most performance domains. If the P-38, which American pilots considered inferior to the P-51, was still superior to German fighters, what did that say about the performance gap? The Germans were not fighting America's best aircraft. They were fighting aircraft that America was phasing out and losing. This realization, perhaps more than any specific technical data, confirmed that the war was lost. The P-38 evaluation is one window into World War II's technological arms race, where engineering decisions made years earlier determined who lived and who died when combat came. If you want more primary source stories like this, deep investigations into the technical and human dimensions of history, subscribe right now. We publish every week, bringing you research other channels never touch. Thanks for watching.